The 2002 National Electrical Code does not specifically address the phasing of 480-volt three-phase systems using the colors brown, orange, and yellow. The National Electrical Code does not standardize these specific color codes. However, the National Electrical Code, in Article 210.5c, recommends identifying three-phase alternating current systems by phase color codes whenever the conductors are visible. The recommended color codes differ based on the system's voltage. For 280Y/120 volts, no specific color code is recommended. For 480Y/277 volts, the recommended colors are brown, orange, and yellow. For 600 volts, the recommended colors are also brown, orange, and yellow. For 1000 volts, the recommended colors are brown, orange, and yellow. It's important to understand that these color codes are recommendations, not mandatory requirements set forth by the National Electrical Code. Various industries and local jurisdictions might have their own established color codes for phasing 480-volt three-phase systems. It is important to consult local authorities and relevant industry standards to guarantee adherence to applicable regulations. When working with electrical systems, especially high-voltage systems like 480-volt three-phase, safety is paramount. Always to energize the circuit before working on it, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Verify the absence of voltage using a reliable voltage tester before touching any conductors. Understand the specific requirements and recommendations outlined in the National Electrical Code, particularly Article 210.5c regarding color coding of phase conductors. Keep in mind that the National Electrical Code provides guidelines and recommendations, but it does not mandate specific color codes for all situations. Be aware that local codes and industry standards may have stricter requirements. Always check with the local authorities and industry standards to ensure compliance with the applicable regulations. Understanding three-phase power systems is crucial for safely and effectively working with electrical equipment. Three-phase power is a type of alternating current electrical power that uses three wires, or phases, to deliver power. Each phase is separated by 120 electrical degrees, resulting in a more consistent and efficient power delivery compared to single-phase power. Three-phase power is commonly used in industrial and commercial applications to power large motors, machinery, and other heavy-duty equipment. There are two main types of three-phase connections, Y and delta. In a Y connection, the three phases are connected to a common neutral point, forming a Y shape. The voltage between each phase and neutral is called the phase voltage, while the voltage between any two phases is called the line voltage. In a delta connection, the three phases are connected in a closed loop, forming a triangle shape. The voltage between any two phases is the line voltage. The National Electrical Code provides guidelines for the installation and wiring of three-phase systems, including conductor sizing, overcurrent protection, and grounding. Always follow the National Electrical Code and any local regulations when working with three-phase power. Proper grounding is essential for safety in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The National Electrical Code requires that all electrical equipment be properly grounded, including metal enclosures, raceways, and equipment grounding conductors. Grounding electrodes, such as ground rods or metal water pipes, must be connected to the grounding system to provide a direct path to earth. Regularly inspect grounding connections to ensure they are secure and free from corrosion. Use appropriate grounding techniques and materials for the specific application and environment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated capacity of the conductors, causing them to overheat and potentially start a fire. Short circuits occur when there is an unintended path for current to flow, bypassing the intended load and causing a large surge of current. Circuit breakers and fuses are designed to interrupt the flow of current in these situations, preventing damage to equipment and reducing the risk of electrical shock. Choose the correct size and type of overcurrent protection device for the specific circuit and load. Ensure that overcurrent protection devices are properly installed and maintained. Regularly test circuit breakers to ensure they are functioning correctly. Use appropriate lockout/tagout procedures when working on electrical circuits to prevent accidental energization. Electrical safety is a critical aspect of working with electrical systems. Always follow safe work practices and procedures to minimize the risk of electrical shock, burns, and other injuries. Wear appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing, to energize circuits before working on them, and verify the absence of voltage using a reliable voltage tester. Use insulated tools and equipment to prevent accidental contact with energized conductors. Be aware of the potential hazards associated with electricity and take steps to mitigate those risks. Regularly inspect electrical equipment and wiring for signs of damage or wear. Report any unsafe conditions to your supervisor or safety officer. Attend regular electrical safety training to stay up to date on the latest safety practices and procedures. Conductors are the wires or cables that carry electrical current from the source to the load. Conductors are typically made of copper or aluminum, which are excellent conductors of electricity. The size of the conductor determines the amount of current it can safely carry. The National Electrical Code provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation method. Choose the correct size conductor for the specific circuit and load to prevent overheating and potential fire hazards. Ensure that conductors are properly insulated to prevent electrical shock. Protect conductors from physical damage by using appropriate raceways or conduits. Use proper splicing and termination techniques to ensure secure and reliable connections. Raceways and conduits are used to protect conductors from physical damage and provide a path for running wires through buildings. Raceways can be made of metal or non-metallic materials such as PVC. Conduits are typically made of rigid metal or flexible metal. Choose the appropriate type of raceway or conduit for the specific application and environment. Ensure that raceways and conduits are properly installed and supported. Use appropriate fittings and connectors to make secure and watertight connections. Grounding electrode conductors, or GECs, connect the grounding system to the grounding electrode, such as a ground rod or metal water pipe. The grounding electrode conductor provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The National Electrical Code specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Ensure that the grounding electrode conductor is properly connected to the grounding system and the grounding electrode. Protect the grounding electrode conductor from physical damage. Use appropriate grounding techniques and materials for the specific application and environment. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current to flow back to the source. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The National Electrical Code requires that all metal enclosures, raceways, and equipment be properly bonded. Use bonding jumpers to connect metal parts together. Ensure that bonding connections are secure and free from corrosion. Use appropriate bonding techniques and materials for the specific application and environment. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Choose the correct size conductor to minimize voltage drop. Reduce the length of conductors whenever possible. Use higher voltage systems to reduce current and voltage drop. Consider using parallel conductors to increase the ampacity and reduce voltage drop. Short circuit current rating, or SCCR, is the maximum amount of fault current that a component or piece of equipment can safely withstand without failure. It is important to ensure that all electrical equipment has a short circuit current rating that is equal to or greater than the available fault current at the point of installation. Failure to do so can result in equipment damage, fire, and electrical shock. Calculate the available fault current at the point of installation. Choose equipment with a short circuit current rating that is equal to or greater than the available fault current. Coordinate over current protection devices to limit the amount of fault current that flows through equipment. Arc flash is a dangerous electrical phenomenon that occurs when a short circuit or other electrical fault creates an arc of electricity in the air. Arc flashes can generate extremely high temperatures, intense light, and pressure waves, causing severe burns, blindness, and other injuries. It is important to take precautions to prevent arc flashes and to protect workers who may be exposed to them. Conduct an arc flash hazard analysis to determine the potential arc flash hazards in the workplace. Wear appropriate arc-rated personal protective equipment, or PPE, when working on or near energized electrical equipment. De-energize circuits before working on them whenever possible. Use insulated tools and equipment to prevent accidental contact with energized conductors. Follow safe work practices and procedures to minimize the risk of arc flash. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. The National Electrical Code is updated every 3 years by the National Fire Protection Association, or NFPA. It is important to stay up to date in the latest edition of the National Electrical Code and to follow its requirements when working with electrical systems. Obtain a copy of the latest edition of the National Electrical Code. Attend National Electrical Code training courses to learn about the latest requirements. Consult with a qualified electrical inspector or engineer to ensure that your electrical installations comply with the National Electrical Code. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with the National Electrical Code and other applicable regulations. Electrical inspections help to identify potential hazards and prevent electrical fires and other accidents. Schedule regular electrical inspections for your home or business. Correct any deficiencies identified during the electrical inspection. Obtain the necessary permits before making any electrical installations or modifications. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. If you are not qualified to work on electrical systems, hire a licensed electrician to do the work. Always follow safe work practices and procedures when working with electricity. Be aware of the potential hazards associated with electricity and take steps to mitigate those risks. By following these guidelines and recommendations, you can help to ensure the safe and reliable operation of electrical systems. Always prioritize safety and consult with qualified professionals when necessary. Remember that the National Electrical Code serves as a guide, and local codes and regulations may have additional requirements. Always check with the local authorities and industry standards to ensure compliance with the applicable regulations in your area. This will contribute to a safer and more efficient electrical environment for everyone.